So to get you used to the wrapping function, let's see if we can plug in particular values of t and figure out what the points should be for the output. Okay? So let's say we have an input of 0. So function notation, w of 0. Oh, wait a minute. If you think about that number line picture, 0 corresponded with just the point 0 on the number line. So in other words, the crust of the pie, you're not eating any pie. If you're not eating any pie, you just get this straight line right here, right? And so this point right here, the length of the arc right here then, it has no length to it. So if you plug in 0, you're not eating any pie, which is sad. So if you plug in 0 for t, that's what this point represents. One-dimensionally, plugging in t equals 0 corresponds in the xy plane with the two-dimensional point 1, 0 for the output. Input 0, output 1, 0. That's kind of a weird one. So t equals 0 corresponds with an output on your unit circle of the point 1, 0. That's kind of weird. Let's do an input of pi over 2. So let's see. Okay, remember how I said we can think of the input as a real number? We can also, on the unit circle, think of it as an angle. What angle, so we're going the other way now, what angle does pi over 2 correspond with? Remember we said the other day 90 degrees, right? Oh, so what does that mean? That means that the crust of the pie for an input of pi over 2 is going to go all the way from here to what would be a 90-degree angle or pi over 2 angle here. Because for t equals pi over 2, that length is going to be the same as the angle measure. So the endpoint of that arc length then is going to be the output for the wrapping function. But this is a circle of radius 1. So what point does this correspond to in the xy plane when you plug in t equals pi over 2? 0, 1, right? X equals 0, y equals 1. So the idea of using the unit circle so that the input can correspond to a real number or to an angle is what helps us figure out what these outputs are, using the angle part of it. So what if I plugged in pi? What does pi equal to in degrees? 180. Oh, so that would be half the pizza, right? So the crust would go halfway around? Okay, so if you plug in pi, distance-wise, you'd be eating half the pizza, you'd be traveling along the crust halfway around. And the end point here is the output for the wrapping function. So you start here, go halfway around. Why? Because that's pi now. It's not pi over 2 anymore. It's pi, or 180 if you go halfway around. So this angle measure is 180, or let's use pi. And then distance-wise, that arc length is also pi. On the unit circle, they're one and the same. So what does that mean? Oh, okay, so what's the output if you plug in pi? The output is that point, the end of the arc. And what is that point? There you go. Okay, I don't think I told you this one the other day, but if you convert the radian measure, 3 pi over 2, to degrees, it turns out to be 270 if you do the conversion. So can you guess then where the arc ends when you plug in 3 pi over 2, if it's 270 degrees? Right there it ends, doesn't it? So it ends here if we're talking an input of 3 pi over 2, which also corresponds to an angle measure of 3 pi over 2 on the unit circle. 270 degrees. So that output, that point right there, is the output. What was that? 0, -1. And then finally, 2 pi, same as 360 degrees, if you're thinking of it in terms of an angle, brings the crust all the way around, the arc all the way around. And where are you back to? 1, 0. So I do that to hopefully make you, or help you at least, understand the wrapping function. Do you feel like you understand it now? Okay, let's do a harder one then, where we're not dealing with the points that are on the axes.